All right, well, in the interest of time, I'm going to get started. Thank you, everybody, for showing up. This is Thinking Inside the Container, a continuous delivery story. It's a talk by me. I'm Maxfield Stewart. I'm an engineering manager at Riot Games. I've been working at Riot Games for about 4 years. I think my anniversary is up in about a week. Prior to coming to Riot, I've done a lot of things over the past 2 decades in the software development industry, from building applications to running performance teams to running an operations organization. Even did a stint as an IT director. In the past 4 years at Riot, I've been helping them solve some continuous delivery challenges as it relates to their software product, which is League of Legends, and I'm going to talk about that in a second. One of the most interesting things about this talk that I want to put in perspective for everything and everybody is that Riot Games aspires to be the most player-focused company in the world, and that presents a really interesting challenge if you're an engineer there. And that's because what we do is we focus on our players. The only thing that matters about everything we build is how quickly we can deliver value to our players. Our players have never heard of things like continuous delivery or Jenkins or Docker, and we can't sell what we do to them in that fashion. So when I talk today, I'm not talking about how Riot believes there's only one way to do things. In fact, that's not it at all. There's 1,000 ways to do what we do. What I'm going to talk about today is a way in which we did one of those things that we'd be willing to change in a heartbeat if it meant we could do something even faster and better for our players. So Riot makes League of Legends. How many people in the room have heard of League of Legends? That's pretty good. That's about a quarter to a half, and that's not all that surprising. League of Legends is a video game that currently, we just announced our numbers, we hit our 10th year anniversary right now. 100 million monthly active users play League of Legends every month. It's kind of crazy when you think about these numbers at this kind of scale. And I'm not putting them up here to brag about how big League is. I'm putting them up here to put it in perspective for the engineers in the room. I know League of Legends is just a video game, but to support this kind of scale, it happens to be one of the largest software platform architectures that I have ever worked on in 2 decades. And to put it into perspective for any build engineers in the room, let me translate it a different way. Riot Games produces 1.25 million builds of software a year. This is just build jobs. This is not just League of Legends. This is every piece of software Riot makes, and this is just what I can currently track. I can't even track everything we build. Today's story is about something I like to call thinking inside the container. I get told I like to tell a lot of stories, but I want to be very clear about this story. This is not about running containers in production, which is something Riot does do. This is about using containers to assist on the build farm, to actually use containers as build environments, ephemeral throwaway build environments, and a tool we used to help make that happen. That tool, backed by Jenkins, currently creates 10,000 to 14,000 containers a week. Think of these as build environments. They get thrown away, but it's quite an effective cluster of containers. It's peaking right now on the Jenkins cluster that runs this around 120 jobs an hour. I think I've seen it peak up to 130, but I didn't get a screenshot, so I can't prove it. Right? It looks as simple as this. The architecture is not much more complicated than here, and I'm going to come back to this diagram and explain the bits in a second. I only put it here to basically state it's simple. This entire system is built out of open source software. You could walk out of here today and put one together on your laptop tonight and roll one into production in a couple of days because you don't have to pay any license fees, and most of this stuff is incredibly easy to install. The story, however, shouldn't start at the end with what we built. It needs to start where this started and why we built this. About 2 years ago, Riot had finished its conversion to continuous delivery concepts and sort of a DevOps philosophy. And when we got to the other side of that, I was still running a build engineering team of about 4 engineers. And what was interesting is that we were getting overwhelmed with requests as a very small build engineering team because we were now building League of Legends 30 times a day. It used to take a day or 2 to get a League of Legends build out, and most of our other software built ad hoc. Suddenly we were in a world where the builds, they just kept coming. And to achieve that, we ended up scaling our Jenkins cluster. Now, we run a single Jenkins master in most cases, and at the time this story starts, it certainly was. And it had over 4,500 unique build jobs on it. And this is what starts to happen when you start to get successful at continuous delivery, is that people just start creating build jobs. The Jenkins master that we were running clocks in at around 800 builds an hour across the entire ecosystem. And it was, at the time, just over 100 unique build servers attached to that Jenkins server, something like 800, 900 executors. I remember when I called CloudBees and was talking about support licensing, they kind of hiccuped a little, and then I hiccuped a little when I got the price tag. But the short answer is, we were expecting more, because what we had done as a build engineering team is we'd made it relatively easy to get a build slave. We'd turned the tables and said, if we stand up a build slave, it's yours. We called it a self-service build slave. Once it's up, you configure it, leave us alone. So people kept asking for more. They liked this model. But we suddenly found ourselves growing. Like, this farm had grown in 2 years from 10 build servers to 100. And in the next year, we were expecting another 100 build servers to get added. And we were starting to think, what the hell are we going to do? Because the way this worked is like any build engineering team at any company I've ever worked. An engineering team needed something from us, they filed a ticket. In this case, we need a build environment. Here's the specs, could you get it set up for us? And of course, in classic build engineering parlance, when their builds broke, we got the worked on my machine, something must be wrong with that VM you gave me because my box works fine. And in reality, the picture looked more like this, right? We weren't getting one ticket, we were getting hundreds. We were buried by these things. And it sucked. It sucked for the build engineering team, but more importantly, if you remember what Riot's all about, delivering value for the players, it sucked for our players because our engineering teams, they couldn't move fast. They had to wait. Every time they wanted to experiment with some new technology or some new way to build something, the build engineering team was literally in the way of forward progress. So we took a stop. We sort of said, wait, what's going on? What do we really want to do? Let's think through, if we're going to change something, what do we want the outcome to be? We knew we needed our engineering teams to move fast. At Riot, we believe in incredibly small, self-empowered engineering teams. We don't believe in big constructs. We're talking 4 or 5 engineers need to be able to build their entire piece of software and run it in production because we'd already adopted the idea of DevOps. An engineering team is responsible for how their app runs in production. We knew we already believed in configuration as code. By this point, we were already using plugins for Jenkins like the Job DSL plugin. Our engineers were programmatically defining their build jobs. But we had this hole. They didn't have great control of the build environments those jobs ran on, and that's sort of what we started to zero in on. We needed them to own the entire stack, including their build environment. And at this time, we were exploring very traditional technologies to achieve this. We have a very large VMware, vSphere, ESXi virtual machine cluster, and we were looking at ways we could have the engineers programmatically build images for that cluster, maybe using something like Packer. We'd have to figure out how to test them and auto-hook them up to Jenkins. Maybe we'd switch to AWS. Maybe we'd do something with Azure. Who knows? Maybe we'd just go deploy OpenStack. I heard that works. We were experimenting with all of these technologies when something happened. It happened very subtly initially. We started to hear little whispers. Well, have you heard of Docker? Do you know what a container is? We're build engineering at the time. We're like, I don't have time to worry about something we don't use. I've got a mountain of tickets to get through. But then it happened. As we crawled through that ticket stack, one of them said, hey, look, we're thinking about putting containers in production. Can you set up a build environment for us that's got Docker on it? And we basically went, crap. All right? The engineers, of course, have found another way to deploy something to production, and that's going to overhaul the entire build system and everything we know about supporting this infrastructure. So we had to go get our learn on. It just started with, well, if we're going to have to deploy Docker to these boxes, we're going to have to learn how to administrate Docker so we can assist these folks. If I end up with 200 servers all running Docker daemons, I want to know what that's going to do to me. And something happened while we were learning Docker. As a build engineering team, we created a lot of build environments and tested a lot of things, and we started to just create those as Docker images and spin up containers on our desktop to test different ways in which we'd configure build environments. And that light bulb moment comes on that was blatantly obvious when I look back at it and said, what if these little test environments we're creating could be the build environment? What if there was a way to get Jenkins to think of this little container on my desktop as the entire build environment? And what if there was a way I could get the engineers to just give those to me instead? I don't have to worry about figuring out how to build Amazon AMIs or OVA files for images. I don't even have to worry about Packer. The engineer just has to write a Docker file. Wouldn't that be awesome? And we liked Jenkins. We wanted to make this work with Jenkins, to be clear, because Jenkins is open source. And at Riot, open source means a lot to us. We're a game company. We're not in the business of making CI tools or making other products. With an open source product like this, as large as Jenkins is, I mean, I heard the number this morning, 440,000 servers deployed. It's kind of ridiculous. But the short answer for us is, odds are if we have a problem, somebody else has that problem too. And all we got to do is talk to them, and we can probably find a way forward. The one thing we wanted to preserve about how our Jenkins system worked ties back to the fact that our engineers were already programmatically defining build jobs. They were already using job DSL to create a Jenkins job, and they were relying on the label, right? So if I've got a build slave that's set up as their build box, it's got a label on it, and they create their build job, and they restrict it to that slave with that label. This behavior was something that was well communicated, well understood, and we wanted to make sure we preserved with whatever we built next. So that led to just a simple checklist of things we thought we'd need to start digging into. We needed to make sure that we could get a Docker container running as a build slave. Remember, this is 2 years ago. Docker was like version 0.6, 0.7, something like that. We needed to make sure that our engineers could give us or find a way to deliver to us a Dockerfile at the time. That's where we're thinking they'd express their build environment. And then we needed the all-important question. Because we were doing 800 builds an hour, we had to figure out, could this system we build support 800 builds an hour? We didn't know. So step one is easy. Can I make a Docker container run as a build slave? The answer is obviously yes, especially today. If any of you have looked into this, there are hundreds, if not thousands, of examples of Docker containers. Here's our example. And in all fairness, there's nothing special about this. This is not the Riot unique build slave. This is just a variant, I think, of E. Varga's Docker container for Jenkins that's online on Docker Hub right now. I threw a few other things into it, like a Git client, made sure wget was there, and I switched the OS because at Riot we're CentOS fans, and this would be more familiar to our engineers. And that was about it. It's really not more than 40 lines of Dockerfile code. And because it was so simple, we're like, well, as long as we're at it, and as long as we're making sort of a base build slave Docker image for people, we can throw all those universal tools that build engineers end up creating and aggregating over time to help interact with things like artifact stores or manage credentials to your custom internal tools and APIs. We can just pop those into this base build image too. And then we can present this as an inheritable build image because Docker has a great sort of inheritance model for images. And any other engineering team can just sort of pack their stuff into it from that inheritance. And it felt pretty good. We got this up and running on our Jenkins server really easy as a build slave. And then we found an engineering team that said, we want to do a real world example, demos don't matter. And we ended up with a Dockerfile that looked like this. And our first lesson we learned came up. Typically, when you hear people talk about Docker containers, they're thinking about the production example. They're thinking about a lightweight container that has nothing but maybe a binary in it and some config files and move it around really quickly. Well, a build environment as a container is the exact opposite. It is this giant, fat monstrosity with tons of stuff in it. Like this one has Percona in it. It's got the JDK in it. It's got some custom binaries and other tools to help with testing in it. It's really heavyweight. Some of our Docker containers were coming in at 3 to 4 gigabytes before image compression. And that meant Docker was a little bit slower than we were expecting to do image pulls and things like that. But it worked, and it was working great, and it was still way faster than using something like Packer to build an AMI for Amazon and get it deployed to Amazon. But we weren't done. When I started this, the real problem was the fact that we were in the way. And while I could get a Docker container up and running and connect it to Jenkins as a build slave, the engineer still had to ask me to do it. Here's my Dockerfile. Can you get everything hooked up? And that means we hadn't solved the problem. We just created some cool tech. So we needed a way to get Jenkins to start provisioning these slaves for us, to auto-configure itself. And we started doing research on that. And to be fair, we didn't know how to do this, so we did what any good engineer does when they're stuck. They go Google their answer. And we came up with 2 possible models. I want to talk about these for a second. The first model is what I like to call the Docker exec model, the permanent build slave model. The idea here shouldn't be that foreign to any Jenkins administrator. I've got a build slave, it's connected to Jenkins in the traditional way. I just install Docker on it. When my build job runs, it executes some Docker commands. I've seen a lot of examples of today here at JenkinsCon talking about this model. And it works great. In fact, this model is best represented by the CloudBees plugin, which basically makes this model way easier to do, and it's a fantastic plugin. The second option is what we were thinking about, which was an ephemeral build environment inside a container. Instead of a build box having a Docker daemon on it, able to execute Docker commands, what if the container was the entire build environment? What if Jenkins thought when that container came up, it was a build box? The advantage to the first model, the one best represented by the CloudBees plugin, is that your workspaces are permanent. And this is going to help any Jenkins administrator who's used to doing things like polling SCM for code changes. If you use Perforce or Git, and you have to have that workspace there on the box in order for polling to work. And when the Docker container comes up, that workspace just gets mounted into it on this box instead. And it's great. And if this is something you need to do, I highly recommend this approach. The other model sacrifices a permanent workspace and goes with the idea that, you know what, I'm going to wipe the workspace every time. So it works best with small code bases, not huge ones, right? And it minimizes the total number of slaves you had. On the first model, we'd still have to configure a build slave against Jenkins and scale our capacity by just adding a build server to Jenkins every time. What we wanted was to just have containers fire up and run build jobs whenever there were builds in the queue. So this was the model we each decided to go with. And at the time, and this is true today, there's 3 basic plugins that can support this in Jenkins. So we didn't have to write any custom code. There's the Docker plugin, which is now, I would actually recommend the yet another Docker plugin, which is a fork of it. There's the Mesos plugin and the Kubernetes plugin. And basically, these are just saying, I'm either pointed to a straight raw Docker server, or I'm pointed to a Mesos cluster, or I'm pointed to a Kubernetes cluster. And they all have the same purpose. They manage the build queue, looking for jobs with labels associated to them that match their internal view of what Docker images should be used for those labels. If they find one in the build queue, they dynamically go spin up a container and auto-hook it up to Jenkins as a build slave. The build job will execute on a single executor in that container, and when it's done, it'll throw it away. And this was perfect. This was what we were looking for. This accelerated our research significantly. We only had to pick one of these, and our choice was pretty straightforward. We didn't have a Mesos or a Kubernetes cluster at Riot, and we weren't interested in setting one up at the time. That would have been more work and a bigger challenge. So we stuck with, well, we can spin up a VM and put Docker on it, and this plugin seems to work with that, so let's move forward. All of these plugins have a similar configuration page. This is a little out of date. It looks a little better now, but it's still, if you're a Jenkins administrator, you kind of groan when you see one of these forms. They're all over the place in Jenkins. It looks complicated, but there's only 3 fields that matter on here. One is, where is the Docker host that I need to spin up the container on? The second one is, what's the label I'm going to associate with a Docker image? And that's the third field, the Docker image. What image needs that label? Everything else you can leave on default, and it pretty much works. And trust me, after experimenting with it, don't touch the numbers, things just break. Like, keep the defaults. And once we were doing this, once we could auto-configure Jenkins, we still found that we were in the way, because engineers still had to come tell us and say, hey, build team, I've got a new Docker image. Could you configure Jenkins for it? Now, it was a pretty lightweight ticket. We just had to go into Jenkins and fill out the form fields. But we wanted the total dream. We wanted to be able to just get out of the way. So we started to ask ourselves, what we need is like, what if there was an API that an engineer could just give an image name and a label to? That API would then just go edit that configuration page in Jenkins. And obviously, this doesn't come out of the box. None of these plugins support that. The existing Jenkins APIs don't really work with the JClouds plugin in this way, at least that we discovered. But it turned out it was easy. One of the things we'd learned after 4 years of administrating Jenkins at this kind of scale was that Groovy was our best friend. When it came to figuring out how to auto-configure Jenkins or monitor various threads or do anything, we do it with Groovy because with the Scrippler plugin, you can execute Groovy scripts and they have access to the Jenkins runtime, the JVM, and configuration on disk. They can literally do anything Jenkins can do. So one of our engineers, he's sitting down here in the front row, his name's Jake Romai, was like, let me whip you something together. And it turned out to be like 100 lines of code. And the best thing about the Scrippler plugin is you can expose your Groovy scripts as REST endpoints. So magic happened. Basically, we created a REST endpoint. It took an image and a label, executed 100 lines of Groovy code, and auto-configured Jenkins for us. And we were there. We'd reached the dream, except for one more problem. Well, now, the engineers didn't have to come through us. They just hit the API, said, here's an image, here's a label, go nuts. And we discovered that they didn't necessarily know how things worked. So if they gave Jenkins a bad image that didn't work as a build slave, crashes would ensue within minutes. These plugins are capable of constantly trying to respin up the build slave if it doesn't start. That's like some of their default code is just keep trying till it comes up. And they can create thousands of containers in just a few seconds and tear down your entire environment before you can blink. And after we realized that's what's happening, we had to put the brakes on and go, wait, all right, engineers, why don't you give us your image name? We'll go check it out, and then we'll add it to Jenkins because we need to make sure you didn't make any mistakes. And we had this small checklist of stuff, but we were doing it by hand, and it was tests, and it just felt bad. We're build engineers. We can automate ourselves out of this problem. So we did. We were a little short on capacity that year, so we hired an intern. We sort of explained to him the problem, and he created us a tool that we nicknamed Harbor Master. If you're familiar with Docker, naval themes are a thing, so it's basically just a meme written as a tool. But all this does is basically take the image name and the label and ask a few questions. Hey, is Java even installed in your image? Because Jenkins isn't going to work if you don't have a viable version of Java in there. As long as we're at it, do you have a viable version of an SCM tool? Riot uses Git and Perforce, so we check for those, right? Do you have file permissions set correctly? Because the Jenkins agent needs to run and have write permissions to the disk. All of these things were getting in our way when we discovered what the engineers were missing. So we ran these tests, and basically we block adding it to the farm. The last bit of magic here is we just created this as a Jenkins job. So an engineer who wants to create a new build slave or update one goes to Jenkins, finds the Harbor Master job, adds an image and a label, hits run. This is a screenshot from the test report we produced using the HTML publisher plugin. They can just get this test report. These boxes would go red if they failed, and it would even have an explanation of why this matters and what they need to do to fix it. So now we're there, right? We got to be there. We have everything we want. Well, not quite, because there's one other thing I mentioned at the start of this. Not only does all of this have to work and get the build engineering team out of the way, it has to scale. And at the time, we were pointed to a single Docker host. So it didn't take long once popularity started to increase on the system. And you look at that one Docker host, even though it was a VM with 16 cores and 64 gigs of RAM, it was working a little hard, and we had to figure out how to add another Docker host to the system. And we had a problem. The Docker plugin can support multiple Docker hosts, but it doesn't do any load balancing. If you put the same image on all of them, it's just, well, whatever's first in the list, I'll put it there. So we were back in the business of going, well, crap, we're going to have to figure out which images go where if we stick with this plugin. And right at that time, Docker came out with something called Docker Swarm. The promise was this. Here is a little agent that supports the Docker API that sits in front of n number of Docker hosts. As far as the API is concerned, you can do Docker build, Docker run, Docker start, Docker remove, all the calls you need to. And whatever is calling it is none the wiser to just how much capacity is behind it. So we asked ourselves, well, will this work with the Docker plugin? How perfect is that API? Well, it turns out perfect enough. The Docker plugin was none the wiser. We configured a swarm, we put a bunch of Docker hosts behind it, we went into Jenkins and we just changed that little form field saying, where's the Docker host, to our swarm endpoint, and it just worked. And we literally threw a party, because at this point, we thought we were gods, right? This has got to be great. Because, just to recap, we had now what we imagined was our perfect flow. An engineer, not a build engineer, could create a Docker file that represents their build environment and create an image out of it and put it in a registry. They would then go over to Harbor Master and ask Harbor Master, hey, I want to add this image. Harbor Master would go, fine, I'll test that. And it's going to pull down the image and it's going to run its tests. And if they pass, we had to add a step. Before we configured Jenkins, we discovered we better go pull that image to this cluster, which at this point wasn't 3 boxes, it was more like 10. Because what happened was, and this is classic, if you just go and add it to Jenkins, Jenkins will dutifully use the Docker plugin to spin up that image, but if it gets assigned to a Docker host that doesn't have the image, it's smart, tries to do you a favor and runs a Docker pull. If you remember, I said these images were fat, like 4 gigs, so that Docker pull would take a few minutes. And if you've been a Jenkins admin with some antsy engineers trying to get work done, there's nothing worse than a build job sitting in the build queue for 5 minutes and not starting. Because they'd literally run up to our desk and go, what the hell, man, your fancy new technology, it doesn't work. My build job's not starting. What's wrong? And by the time we're lazy build engineers, we go, yeah, fine, we'll go look, and looked at it. It already started, right? This was waiting for water to boil problem. So we discovered if we pulled the image first during the Harbor Master run, they were very patient waiting for test results. So it worked better. They didn't say, oh, like the Harbor Master log would just say, now I'm pulling your image, please wait. Once it's done, it would hit the API we created and auto-configure Jenkins. And then we had one new problem. So the instant this got popular and people started to use it, we had forgotten why we started this journey, because our engineers wanted to build Docker images to put containers into production. So some of the first thing the teams did that were already familiar with Docker, they hopped on this bandwagon in a heartbeat, went into these Docker files where they were creating their build environments, yum install Docker. And then they go run Docker builds in their builds. And this is essentially Docker in Docker. Back 2 years ago, this was a often debated thing as to whether or not this was even healthy to do. All right? What it did to us is very simple. If I go back for a second and look at that swarm, all right, whenever they ran a Docker build call to create an image in the environment, it didn't know where to run, and that's fantastic. I'm getting paged during the conference call. Sorry, folks. What would happen is that Docker build would run against the swarm because the default Docker host environment variable was the swarm. And then suddenly the swarm, all these boxes would fill up with all these garbage builds, because one thing that happens in a build environment is not every build works. Some builds crap out. Some people create fork bombs out of test scenarios. Things go wrong, and it was clouding this Docker host cloud, and then it was causing Jenkins to crash because it couldn't spin up containers. So we needed a solution, and it turned out to be really, really simple. We just stood up a separate Docker host. We called it dry dock to stick with the naval themes. And then we overrode the environment variable for Docker host across the entire cluster using Jenkins, so that whenever anybody inside one of their shell scripts executed a Docker command, we're actually forklifting them onto this other box. And this box could deal with the reality of the fact that sometimes people screw up, because if this box ever got corrupted or broke, we literally just wiped it and dropped a new image in place and brought it back up, and problem was solved. And while I'm talking about it, I mentioned earlier that our engineers programmatically define their build jobs. So the way in which they use this system looks a little like this. This is pipeline. This is one of the ways. They also use classic build jobs and job DSL. But I found pipeline is the easiest way to express it. There's nothing different you have to do to use this. You just assign a label. There it is, awesome build label, right? And that'll spin up a Docker container, because it's just like any other job, it goes into the build queue. And just for giggles, because I think it's fun, this is a classic example, and it always irritates me when people show basic examples. So this is a little more familiar to what we're using for pipeline for our Java jobs. Now, this is just a DSL. This is a wrapper. We actually use the global libraries for pipeline DSL, and we create something called a Maven build construct, where all the engineers have to do is basically fill out a form field of metadata. And it's a little bit more heavyweight than a Maven clean install, because our build environments and what we do for our build jobs is a little more heavyweight. That's best explained by sort of the pipeline UI. So like everybody, we do git syncs, and we have to start the container, and we run unit tests. Then we have to package up what you've created. And at Riot, we have a lot of different deploy tools. Remember, I had cracked a joke about, oh, look, the engineers came up with yet another way to deploy to production. Some of the Java builds that they create need to deploy to our old deploy infrastructure, and some need to deploy to our new containerized infrastructure. One pipeline build job can handle building both packages and making sure that those get to the right places. So in the end, we'd achieved something. Perhaps our build engineers could drink some Mai Tais on the beach, because that is a far cooler job to get paid for than what we were doing, which was filing tickets. So if any of you are in here, are engineers in the room going, sweet, how do I build this thing, right? That's what you're going to talk about next. I don't have time. I only got 30 minutes in this presentation. I have been writing a blog on the Riot Games engineering blog that walks through 6 or 7 tutorials of also learning how to run Jenkins and Docker, as well as this model. But if you don't have time to go read 6 or 7 blogs, you can go to my personal GitHub and just download it. There's 2 variants there. There's like tutorial 7. You can download that one, and it will work with Jenkins 1.6. Working with Jake while we were here at the conference, we also created a Jenkins 2 variant that just works. Download it. We'll get everything up and running on your desktop so you can play with it and experiment with it. It's really, though, not that simple. Well, at the end of a 2-year adventure, I can get up here and talk about it and go, look, just go sync a GitHub page and everything works. We learned a lot of lessons along the way. So before you run out of here and go, oh my God, we got to do this, or oh my God, he's smoking crack, it can't possibly be that easy, you're right. There are some lessons learned. The first is that anybody who sells you Docker is easy, containers are the next new age thing, that everybody should do this, I would say think carefully. Yes, I agree containers are awesome, but they're not easy. They're only easy for people who have been spending time already creating images and virtual machines and configuring environments. If you're going to say, hey, engineer who has never used Docker before and probably has never remoted into even a Linux slave and done a yum install, it is a little intimidating. And this was our first roadblock. Once we got past the engineers who knew this stuff, we had engineers who go, I don't know, that Docker thing, I read this article from boycottdocker.com, and I think it's terrible, right? Rather than create mountains of documentation to them and force them to do it, we just switched our attitude and said, look, are you looking to do this? Give us an hour, give us 2 hours. Within 2 hours, we're gonna sit down with you, we're gonna create baby's first build environment, and you're gonna be up and running. We guarantee it. So rather than taking a ticket and doing work for them, we would take a request, schedule an hour, and sit down with them and train. And that initial hurdle, I'm still getting paged, which makes me very panicky, but there should be somebody else answering that call. Oh, that's classic. I can't believe I'm being paged while I'm up here. It's great. Anyway, the training worked, and they got over the hurdle, and they ran into problem number 2. Problem number 2 is that when we started this, we were kind of thinking as containers are just replacements for virtual machines. In fact, I even sort of pitched it that way at the start of this talk. They're not. And today you can find a lot of ample material on this and how they're different and the ways in which they're different. But back then it was a little harder. So I can put it to you in more blatant context. One of the things we were doing with our virtual machines is we were mounting remote file shares from things like NetApp devices. Well, you can't network attach storage inside a Docker container. That's one example in which they're just not VMs. They do differently. You can mount a file system into that container so long as it's mounted on the host, but we didn't want that. Our hosts, we wanted to keep as dumb as possible, as easy to spin up as possible. So we had to get over this hurdle and find new ways to do things. In that particular example, Samba client was a great fix to our situation, but we had a lot of other little niggly details we had to get through. The other thing is that these are ephemeral and they don't maintain state. So if you're coming from a world where engineers are used to VMs sticking around for a while, these don't. And the first time that they really grok what that means, that anything they left behind as a temporary file in their build job that they could go look up the next time their build ran wouldn't be there, they had to alter how they think about these problems. The third lesson we learned is that when you start running a large Docker cluster, there are things that Docker does not do for you out of the box. These are the things that give you the heebie-jeebies as a systems administrator, because you know installing third-party software in your machines is going to do something you didn't really conceive of when you did it. And in our case, Docker leaves a lot of cruft behind. When anytime somebody runs a Docker run or a Docker build, there's a chance that Docker doesn't clean up correctly after itself, so it leaves a stopped container. Or maybe that build job was running some tests that just crashed horribly, and the whole container's exited. If you're not keeping the Docker host clean of this stuff, you're going to run out of disk space. One answer is to just like throw them with 3 terabytes of storage, but that's not really cool or sexy. And as we were thinking about this problem and literally starting to write our own tool, Spotify open sourced a tool they call Docker garbage collection. And it does 95% of what we needed. So we just grabbed that puppy, threw it in a Docker container, and ran it on every host on the server, and never looked back, and thanked the open source gods for solving our problem for us. The fourth one, again, this comes down to running a lot of servers. It's not unique to Docker, but it is unique to running a homogeneous cluster of servers that need to do a purpose. And that is, how are you going to maintain them? One of my favorite stories is at the time we stood this up, we were using Docker 1.8 when we finally got the wheels really moving forward. Docker 1.8 had a really gnarly bug in it. And that is on a Docker pull, it would hang, and then it would never be able to pull that image again until you restarted it. And for a system like this, that sucked. So we needed a way to find those boxes, pull them offline, and restart them and put them back online as quickly as possible. So we created a little Python script that we call Kraken, mainly because it's fun to say release the Kraken whenever there's a problem, right? And it would roll through and clean all these up. And that script actually proved super useful for all kinds of maintenance on these machines because it just had the commands needed to pull a box out of the swarm, stop Docker, do some cleanup, start Docker, put it back into the swarm. And that leads to the next problem. Granted, if you're the type of person like we are that never uses the Jenkins LTS version, you're always on Jenkins latest, you're well aware of chasing the wheel of versions. There's always a new fix. Docker's the same way. There's always a new Docker version about 3 or 4 months out or just released. If you go into this and go, just upgrade, it'll be fine. You're going to get stuck, just like you would with any other software. The point I want to raise here is if you're setting up this model where you have Jenkins talking to Docker Swarm, talking to a bunch of Docker hosts, if you change your Docker version on the Docker hosts, you need to test whether or not Swarm can still talk to them. If you change the version of Swarm, you need to test whether or not Swarm can still talk to your Docker host and whether or not Jenkins can still talk to it. If you change your version of Jenkins, you need to test everything, because quite frankly, plugins break. We all know that. And these are things we've been burned by throughout this process. One of the reasons I took the effort to spin it all up in Docker containers on my desktop is to facilitate the testing of this, to facilitate automating, just getting one stood up, starting a build. Does it go into the queue? Does it provision? Does it start? Does the job end successfully? Sweet, then it's probably still stable. And the last one is security. And this isn't unique to Docker. If you're thinking about ephemerally provisioning build slaves using images, unbelievable. I have to go talk to my team after this call. If you're using images or Docker containers to ephemerally spin up build environments, you need to ask yourself seriously, what is in those images? What's going to happen is people are going to automate the hell out of everything they do, and that means they're going to throw into these things AWS keys, SSH private keys. They're going to put in usernames and passwords to all of your tools and endpoints and artifact stores within your build environment. And if you worry about security, you worry about some intruder getting a hold of these things. And if it's all in your Docker image, all they've got to do is get access to wherever your artifacts are and pull one down, and they have keys to the kingdom. This would be true if you were building an Amazon AMI as well, or any image for any virtual device. It's the same as locking down your build box if these things are on there. The problem was, in the old world, they'd get a box, it would be protected by a root login and a password, and they'd set up some users, they'd remote in and configure it, and they'd rely on the security of that machine to protect these kinds of things that are traditionally just auto-configured on a permanent box. Well, in a Docker container, that stuff goes away. You have to add it every time. So you need a solution to this problem. Ours was to inject as much as possible. Rely heavily on the credentials binding plugin for whatever credentials you can get in there that way. If you can't do it that way, inject environment variables. And if you can't do it that way, stick up some kind of service that is a third-party secret service that can retrieve data for you when your build jobs start. Try not to put it in the images. So as I'm approaching the end of my story, the all-important question for me was it worth it? We created a lot of cool technology. The theory was we were going to unblock our engineers and be able to move forward. So today, we have something we call Docker Jenkins, and that's where all build jobs as Docker containers run. And this is a capture from some of our metrics from it. Once we stood this up, and this was about a year and a half ago where we decided we were out of beta and this would be available to every engineering team at the company. Within about a year, over 1,500 new build jobs were created solely on this particular Jenkins cluster. In that time, we had a net 200 job reduction in the original Jenkins server. So while I didn't get to eliminate my original Jenkins server, I didn't increase any load on it. Nobody went back to create more jobs there. They actually adopted the new model. Now, there are exceptions. Riot builds a lot of software on Windows and OS X, and you can't do that with Docker containers, so those guys still had to go to the old cluster. But even with that kind of work going on, net job loss on the original cluster, tremendous job gain on this one. You can see some other neat stats there. Happy to talk about these after the talk if you're interested. The other thing that I found really compelling when I dug into the data is over 50% of all of our build environments at Riot are now represented as Docker images. And that's pretty impressive. When we started this, we had about 100 build slaves that could theoretically be transposed to build environments with some exceptions. When I went before this talk and came out here, I have 137 Docker images representing build environments. So that means while we have fewer jobs, we have more build environments. So there's also a subtle piece of success in there. We gave our engineers more creative freedom over how to configure their build environments because they no longer had to make a single box because they were waiting for a ticket to get another one. They didn't have to make one box do 10 different things. They could just make 10 different Docker images to be purpose-built for those goals. And all those tickets I was talking about, they basically disappeared. Once we trained enough teams, there was sufficient documentation around the company to figure out how to create your own build environment as a Docker file, run it through Harbor Master, and get it running. So we stopped getting these requests. And that meant something pretty compelling. There is no longer a central build engineering team at Riot Games. We didn't fire them for failing. What we discovered is once we'd eliminated all of the blockers to our engineering teams, the nature and the role of the build engineers had to change. They no longer had to be a service team. They were now experts. They weren't just experts at how to create continuous delivery pipelines. they were experts at Docker. Some of those engineers, like Jake here down in front, went and joined other development efforts at Riot to help them figure out how to ship their software. Other engineers went and joined our cluster engineering team. That's where I am today. I'm helping figure out how to optimize how we run containers in production, because the build environment use case turned out to be a more difficult problem than just running permanent containers in production. So that's where we are today, and that's pretty much the end of my conversation. I'm happy to take questions if they're available right now, though I'm not sure I can see hands raised. If there are no questions, sweet. Thank you very much for coming. So the question is, have we open sourced any of the tools we've created? A lot of it is the Groovy scripts I talked about to create the API, how to get Jenkins configured, all of that's available on the public GitHub. We haven't open sourced Harbor Master yet. It turns out there's some specific Riot use cases in there that won't meet the open source standards we aim for. That said, it's really easy to write. So if you want to talk to me offline, I can literally give you the commands. You could write it, we wrote it in Golang, but you could write it in Python or even Bash probably. It just has to do those basic tests. I see your question, I think. All right, so the question is, hey, you kind of blew over that dry dock point. What was the value of that? Was that for where to put images after they passed Harbor Master tests? Actually not, but I can understand the confusion because I did roll through that really quick. This took a little nuance to understand, but a build job, if you think about what happens when somebody needs to create a build job that creates a Docker container, in this model, the first thing they have to do is create a Docker file that represents their build environment. And within that, they're going to install the Docker client so that they can call Docker when they spin up their build job, probably with a shell script or something like that. The build job will spin up. It'll ephemerally create a container in this environment. And then they get to the point where they're ready to do a Docker build. Docker build has to run against a Docker server. This was something I had to learn when I was first doing it. I thought it was just right there on my client. But no, it actually puts everything together on a Docker host somewhere. By default, that Docker host was this build cluster we had created that we thought's only thing it was doing was running build environments. So we created dry dock so that we had a place to do things like Docker builds. Or in some cases, some teams were starting to actually spin up containers to do integration tests, and they'll spin those up on dry dock as well and run those tests over there. That way, if they break that stuff, it doesn't break our build environment cluster. All right, there were some questions heading this way. So I saw his hand before yours. I'm going to come to you next, in the back over there. All right, so the question is, how do you maintain these containers? How do you update them? Like, we all know build environments aren't static. They don't get locked in stone. Part of it is understanding the difference between a container and a Docker image. The container goes away after the build job is done, so sweet. Every time a new build job starts, I get a new container based off the image. So what we're talking about is how do we update that image? All they have to do is go back to Harbor Master. If they're versioning their build environments as Docker images and using a version tag, they go to Harbor Master and say, hey, I nominate this one to now be my Vault build environment. It's got this version tag. Harbor Master reruns the tests on it. If they pass, it goes ahead and replaces what it thinks on our artifact store as their build environment. And Jenkins now uses the new versioned image that they created. Does that answer your question? Sure. So the question is, hey, you mentioned that you can't remote mount file systems inside Docker containers. How do you actually solve that problem? So the quick answer is we switched over to we install Samba client into our build slaves because all of our network file shares are just CIF Samba stores. So we kind of treat it like an FTP call. Instead of where before they could just copy or write to that folder, they now have to call Samba client to copy or write to the folder. That's just one solution, though. I wouldn't say that's the right solution necessarily for all use cases. The other way you could do this is on the Docker host itself. You could still, FS tab and mount that folder. And then every time you start a build container, you could mount that file system into the container. We chose not to do that because it meant a little extra configuration on every build host, and we wanted to see if we could get away with as little as possible. Both are really viable options, however. Yeah, I get asked that a lot. So what creates these? I keep meaning to write a blog on how to set this up because it is also all open source tools. The front end for this is Grafana. There are actually multiple data sources on the back end. So I use the Jenkins metrics plugin to exude metrics to a Graphite database, which I'm actually just running in a Docker container somewhere. There's a couple other things. On every single Docker host, we run, Google's provided a pretty kick-ass little tool called CADvisor, which exports metrics about the host itself to an InfluxDB. So I'm running an InfluxDB in a Docker container somewhere. And then we also wrote our own custom monitor because there's some things, you can't see it here, but there's some things we wanted to know, like how many images and how many containers are on the box. So we wrote our own little Python script that got that data and just wrote those to the same InfluxDB that CADvisor is writing to. Grafana is awesome because it can read data from Graphite, from InfluxDB, and like Zabbix and a bunch of other sources. It just has little plugin drivers for its data sources. So we can aggregate it all on this dashboard, which made it super convenient. Are there any other questions? Okay, if I'm not seeing your hand because the lights are on and I can't see you, I'm sorry, come find me. Thank you very much. I think I'm going to circle back over here with somebody who was asking about how to configure the containers. Thank you, everybody. Thank you very much for coming.